We're going to begin working with complex numbers, and to start with, just the imaginary number, where the lowercase script letter I is equivalent to the square root of -1. So here's just some simple I math. If I have I squared, that's the same as saying I times I, because those both have invisible ones as exponents, and 1 plus 1 would make 2. Well, if I is equivalent to the square root of -1, then I times I is the square root of -1 multiplied by the square root of -1, and whenever you square something, it simply takes those and eliminates them. So the answer to I squared is simply -1. Let's look at I to the 12th power. Well, if I want to do it the same way I did the first example, that means I can write out a whole bunch of I's 12 times. And then I can group them in pairs to find the results of -1. And then I can take all those -1s and pair them up to get positive ones. And +1 multiplied by +1 multiplied by +1 is just 1. So apparently I to the 12th power is the whole number 1. I to the 18th, well, I could shorten that up, and I could say that that's I squared to the 9th power. And the reason why I would do that is because in example number 1, I discovered that I squared was -1. So I could say that I squared to the 9th power is the same as -1 to the 9th power, which means that -1 to the 9th power is, of course, -1. When you have a negative number, or an odd number of negatives, you get a negative answer. So how about an odd exponent, I to the 23rd? Well, I could break that down as I to the 22nd times I, because again there's an invisible 1 here, and 22 plus 1 is 23. I know that I to the 22nd power could be I squared to the 11th power, because 2 times 11 is 22. Here's that single I again. We learned up above that I squared is the same as -1, so really I have -1 to the 11th power. And again, having an odd number of negatives means I end up with a negative, so that's going to be -1 times I, which is just -I. If you play with I long enough, you're going to find that it has a nice pattern. I'll give you a hint. There's only 4 pieces to the pattern. Write it out. See what happens. With complex numbers, you can do addition and subtraction problems. If I have 4 plus 6i as a quantity, plus 7 plus 9i as a quantity, a good way is to rewrite the problem so that like terms are grouped together. So I would recommend rewriting this as 4 plus 7 plus 6i plus 9i. And now it's very easy to see that the 4 plus 7 makes 11, and 6i plus 9i makes 15i. And I'm done. Now with subtraction, you need to be careful. What I like to recommend to my students is to remember that behind the minus sign in between the quantities, that there's really an invisible 1. So I really should distribute the -1 through the quantity of 7 plus 9i. So it becomes an addition problem. 4 plus 6i plus in the quantity -7 minus 9i. And the reason why I do that is so, like in problem number 1, I can rewrite the like terms next to each other. So this would be 4 plus -7 plus 6i plus -9i. 4 and -7 make -3, and a 6i with a -9i make a -3i. So the final answer is -3 minus 3i. We can also do the distributive property with complex numbers. All you have to worry about here is the coefficients. For now, this I is like an x or a y or a p or a q. 2 times 4 is 8, and 2 times positive 6i is positive 12i, so the answer is 8 plus 12i. Simple distributive property. 2 monomials being multiplied. 2i multiplied by 7i. Well, 2 times 7 is 14, and I times I is I squared. But we learned in the previous section that I squared is the same as -1. Things that are side by side should be multiplied together. So this should really be the problem, 14 multiplied by -1. So the final answer is -14. We can also do foiling, stacking, or Punnett squares. Think of it however you want, but we're going to do the problem 2 plus 2i times 3 plus 4i. 2 times 3 is 6. 2i times 3 is 6i. 2 times 4i is 8i, and 2i times 4i is 8i squared. Combine the like terms in the middle, and it looks like I have a nice trinomial, 6 plus 14i plus 8i squared. But again, what is I squared? That's right, it's negative 1. And when things are side by side, we should multiply. So I need to simplify the 8i squared as 8 times negative 1, which is really negative 8. And now I have two more like terms with the 6 and the negative 8. Remember that the normal-looking number we always like to put first and the imaginary number last. So the final answer is really negative 2 plus 14i.